We're going to look at roots today. Roots of numbers and roots of expressions with variables in them. Well, if we take a look at this here, the nth root of x, n is referred to as your index. Basically, you're wondering what number multiplied together n times would give you x. So this one here means 0 times itself 5 times, or what times itself 5 times gives you 0. That is 0. Or this one here, what times itself 4 times gives you 16. Or another way to think of it is what to the fourth power is 16. And that's really what we're trying to figure out. So this would be what to the third power is 27, or what times itself 3 times gives you 27, that is 3. Same idea down here, what times itself 3 times gives you negative 8, and that's a negative 2. And what times itself 4 times gives you negative 16. Some of you might be thinking, well, it's 2. Well, 2 times itself 4 times is positive 16. A few of you may be thinking negative 2. And a negative 2 times itself 4 times is positive 16. So neither one of them work. There's really no real solutions to this. There are numbers that work, but not in the real number system. Now, as we're going through this section and for the whole rest of the chapter, you're going to want to be familiar with these numbers over here in the white boxes. If you come across any of these numbers, you want to say, oh, I could rewrite that. Like 81 right here. 81 is really a 3 to the fourth power. 81 is also a 9 to the second power. A lot of times, though, you're going to want to try to write it in a smaller base. So that would be your 3 to the fourth. So I would go ahead and copy this chart down in a place that's easy reference for you, like the front of your notebook inside the cover or something like that. Well, let's start taking a look at roots. Here we're dealing with a square root, so I want to go ahead and rewrite everything on the inside of my root as something squared. 16, you should know, is a 4 squared. Well, an x to the 6th is really an x squared times another x squared times a third x squared, because remember, when you're multiplying your bases, you end up adding your exponents. Your square root then undoes each one of these squaring. So your square root undoes the square in the 4, undoes the square in the first x squared, undoes the square in the second x squared, undoes the square in the last x squared. So we have this. Well, a short way to write an x times x times x is an x cubed. A second way we could have done this problem is looking more at exponents. A square root is really a 1/2 power. So we'd have our problem, and now all we'd have to do is say, oh, we have an exponent raised to an exponent, apply that exponent to each one. Remember, an exponent raised to an exponent, you want to go ahead and multiply those exponents, and you will get the same answer. Taking a look over here, we once again have a square root, and we have something to a fourth power. So I should be able to write it as a couple of squareds like I did over here, or I could go ahead and use the exponents, remembering my square root is a 1/2 power. Then I can take this square, or 1/2 power, times this exponent here, because it's an exponent raised to an exponent. Half of 4 is 2, and I would get this, and we'd be done. I cannot apply my squared right here to each one of these on the inside because there's a plus or minus sign here. I can only apply my squared right here to the inside when it's all multiplication and division. Here we have a fifth root. 243 showed up in that list of numbers. So we're going to rewrite everything on the inside as something to the fifth power. 243 is 3 to the fifth. A to the 10th. 10 is larger than your 5 in front. So we're going to go on a to the 5th. Well, that would leave us with a second a to the 5th. Because remember, you got to add your exponents. And same type of thing on your b's. b to the fifth, b to the fifth, and another b to the fifth. Your fifth root here undoes each one of these fifth powers here. So your fifth root undoes all your exponents, so it only leaves you with the 3, the a, the a, the b, the b, the b. Well, a short way to write that, since you have an a times a is an a squared, or a b times b is a b cubed. Here we have the square root of a negative. And well, nothing works to give you the square root of a negative. Now, if it was the cube root of a negative, well, that's a different story. But if it's a square root of a negative, you can't work it out. So we're back to a square root again. So once again, rewrite the inside as something squared. Remember, with your x's here, you add your exponents. Your square root undoes each one of your square exponents, so it leaves you with this. Short way to write all those x's is an x to the fourth. Here, square root, so you could rewrite the inside as something squared. So your first parenthesis squared, well, that's only, we need to get up to 6. We only got it up to 2. So you got to add another one of those, and then really a third one, because you got to take this exponent plus this exponent plus this exponent to get this up here. Then our square root undoes each one of our exponents. So this square root right here, whoops, kind of messed up my square root, it undoes each one of our squaring. So you're left with only the parenthesis stuff. Well, you have the same parenthesis multiplied together 3 times, so you could write it like this. If you wanted, you could have used exponents here, remembering your square root is really a 1/2 power. Then you could apply this exponent to that exponent. It's an exponent raised to an exponent. You multiply them, you get 3. And then once again, we cannot apply this exponent to what's on the inside because there's a plus or a minus sign here. Fifth root. From that list of numbers you copied down, you should remember that 32 is really 2 to the fifth. You have your x to the fifth. Your exponent here is bigger than your index of 5 in front, so you could write that as a y to the fifth, and then you'd have to have an additional y to the fifth in there to be able to get those to add together to give you your 10. Your fifth root undoes each one of your fifth powers. Short way to write your y times y is a y squared. Here we have the square root of an even number that's negative, so it does not work. Here we have the sixth root of t to the sixth. The root and the exponent undo each other, but its absolute value. Because consider this here. 2 to the sixth root, is just 2. But a negative 2 to the sixth power is positive 2. Same idea over here. And if you wanted to double check these on your calculator, you could. So whenever you're dealing with a even root here, what you get out then will be this sign that you have in front, which is positive. So to ensure the inside's positive, you have to use absolute value. Over here we have a fifth root, so we're going to rewrite stuff with fifth powers. 243 is 3 to the fifth, x plus 2 to the fifth, x plus 2 to the fifth, x plus 2 to the fifth. Your fifth root undoes all your exponents of 5. They disappear. Short way to write that then is this to the third power. Even root, so you know you got to get a positive out. Cube root, 27 is a 3 cubed. Write this as something cubed times something cubed times something cubed. Remember, you got to add your exponents here together to give you that 9. Your cube root undoes all your cubing exponents, leaving you with what's left. And then the shorthand way to write that.